This conference will now be recorded.
Good evening, one and all. This is Rajesh. In our subject embedded system design, our fifth unit task communication. In our previous video, we covered the topics shared memory, message passing, remote procedure call, and sockets, and task communication. Uh, in this video, we'll see what is a task synchronization and what are the issues, device drivers, and how to choose an RTOS. So, our textbook is Introduction to Embedded System by Shibu KV. So objective is to learn what is task synchronization, its issues, device drivers, and how to choose an RTOS. So you know what is an embedded system. Embedded system is a unique system, combination of hardware and software doing a specific task, and all medium and large scale embedded systems will depend upon the RTOS, which defines the way how a system must perform. So embedded system is an electromechanical system doing a specific function. These are the examples of embedded system. So you have seen what is a OS, general purpose OS, and RTOS. And RTOS has a kernel, which kernel has a set of services, and these services are memory management, time management, file system management, and this kernel and operating system is stored in a kernel space. Then it is a monolithic kernel. If it is required part is stored in the kernel space, and some other irrelevant other than relevant data will be stored in a user space. It is called servers, and this operating system provides the concept of task synchronization and memory management. So you know what is a process and task. It is a process is a program in execution. It consists of a program counter, stack, and data selection. And for multitasking, you need to see that all the tasks uh, share the resource by using scheduling algorithms, and each of the tasks can enter into run state, ready state, blocked state, terminated state, or new state. So this is a state diagram showing the transitions. Task communication will occur in two methods: cooperating process and competing process. um, Shared memory utilization is done by pipe method, signaling method, and for memory management, memory allocation. Your mailbox is another method, and remote procedure call is an inter-process communication. So in this topic, we'll see what is task synchronization. Task synchronization means in a multitasking environment, multiple processes are running concurrently, sharing the same system resources. So for each process, it has a boundary wall, and they communicate with each other with different IPC mechanisms, including shared memory and variables. So it's like two processes are trying to access same display hardware and providing inappropriate results. So the act of making processes aware of access of shared resources by each process. So each process or task is utilizing shared resources, but they should be aware of access when they should access, whether the shared resources is free or not, or it is utilized by another task, and what data must be exchanged between multiple tasks. So all this information must be shared by them. So or else they must be shared by them to avoid conflicts. So that is called synchronization. Various synchronization issues may arise in multitasking environment if synchronization is not followed. The following section describes about the synchronization techniques. So first one is the racing. The synchronization techniques are racing. The two processes are running, and racing is a condition where multiple processes are competing for access to the shared resources concurrently, and the final value uh, of the shared data depends upon which process has shared recently. Finally, okay. And deadlock is a condition where two processes are competing for a process, and ultimately the resource is not utilized by both of them, and they are in a deadlock situation. And this deadlock situation is leading to mutual exclusion, where only one process can hold the resources at a time, and that may lead to hold and wait state, or no resource preemption, or circular wait. The condition in which a process holds a resource by acquiring the shared access and waiting for additional resources. So it is getting access, but it is unable to use it. No resource preemption, the criteria that OS cannot take back the process currently holding, and the resources cannot be released by a. So there is circular wait, where a process is waiting for a resource which is currently held by another process. And deadlock handling. So deadlock handling means a smart OS may foresee the deadlock condition and will act appropriately to avoid such a situation. So this is a deadlock condition where all the four ways vehicles are coming and they are unable to utilize the situation. So leave lock is similar to deadlock, but where deadlock process enters into a wait state and further it cannot progress. In a leave lock, it is unable to make any progress in execution. If two people are trying to move through a narrow place and each of them move apart and none of them are utilizing the thing, that is a live lock. Starvation is a condition in which process does not utilize the resources, and they need resources for a long time and they are unable to get the resources, and for this priority. So starvation may arise due to various conditions by providing byproduct of starvation may arise due to various conditions like byproduct of preventive measures, deadlock, scheduling policies, and tasks with shortest execution time. So starvation is a condition in which a process does not require the resources required to continue its execution for a long time. So there is a dining philosopher problem. This is in dining philosopher problem. Each of the persons sitting on the dining will be in the three states. Either they will be eating state, or they will be in the hungry state, or they will be in the brainstorming state. And in dining, the five persons sitting on the dining table will be provided five forks. But in order uh, to be in the eating mode, they require two forks, and they can be in a hungry mode or they can be in a brainstorming mode. And this by brainstorming dining philosopher problem is an example for synchronization issues. Another is producer consumer or bounded buffer problem, where a thread or process which produces data is called producer. A thread or data a thread or process which consumes the data is called a consumer thread or process. So imagine the situation where the producer thread is keeps on producing the data and puts in a queue called buffer, and consumer thread keeps on consuming the data through the buffer, and there is no synchronization. Then there are two cases occurring: buffer overrun or buffer underrun. Buffer overrun occurs when producer tries to pull the data, uh, produce the data, uh, and at a faster rate, and it is consumed not consumed by the consumer. Buffer underrun occurs when producer is unable to produce the data, but consumer requires to be accessing more data. So another synchronization issue is reader writers problem. This reader writer problem is one where uh, one process tries to read the account. At the same time, available balance must be updated by another process, and it is leading to inappropriate results. So these are the four synchronization issues occurring. One is racing, another is deadlock, another is live lock, another is starvation. So for which some problems are provided. uh, dynamic philosopher problem, and producer consumer problem, and reader writer problem, and these are solved by synchronization techniques. So what is priority inversion? Priority inversion is a combination of process synchronization and preemptive priority scheduling. So priority inversion is a condition in which a high priority task has to wait for a resource due to low priority task. And priority based preemptive scheduling technique ensures that a high priority task is executed first, whereas the log based process synchronization like mutex semaphore ensures that process will not access the shared resources in use by another process. The synchronization technique is only interested in avoiding conflicts that may arise due to concurrent access of shared resources, and not at all bothered about the priority of the process which tries to access the shared resources. So these are device drivers. As you know, your OS is connected to your hardware and your user applications. Your user applications are connected to device drivers. Device drivers are nothing but it is a software program which tells the specifications of each devices connected, what is the data rate, how data is transferred serially or parallelly. So device information is written in the device drivers, and OS, the core of the OS kernel will read the device drivers and understand how each device is configured. Then only the user applications can interact with the devices. The architecture of OS kernel will not allow direct device driver. So all the device related access should flow through the OS kernel, and the OS kernel routes it to the concerned hardware peripheral. The OS provides interfaces in the form of an application program interface. The device driver abstracts the hardware from the user applications. So device drivers needs to be installed on the fly for communication. For installed drivers, the driver is loaded on a need basis, and the device managed services of OS kernel is responsible for loading and unloading the driver and managing the driver. Device drivers can run in either user space or kernel space. If they run in the user space, they are called user drivers. If they run in the kernel space, they are called kernel drivers. User mode drivers are safe compared to kernel drivers. If an error or exception is occurring in the user space, you can emit only those services of the kernel. But if it is occurring in the kernel mode driver, entire kernel will get crashed. So interrupt handling and processing, client interfacing. The basic interrupt configuration involves the following: set the interrupt type, level triggered, enable the interrupts, and set the interrupt priorities. The processor identifies an interrupt through an IRQ. IRQs are generated by interrupt controllers, register an ISR and IRQ. Whenever an interrupt occurs, depending on the priority, the corresponding ISR is invoked, and the processing part of the interrupt is handled, and the whole interrupt processing can be done by invoking an IST. The IST performs interrupt processing on behalf of interrupt ISR. It is always advised to use an IST for interrupt processing. So whenever an interrupt is occurring, depending on its priority, corresponding ISR is invoked. The processing part of an interrupt is handled in an ISR. The whole interrupt processing can be done by ISR by invoking an interrupt service thread. The IST performs interrupt processing on behalf of ISR. So how to choose an RTOS? That is depending on two functional and non-functional requirements. Functional requirement tells that it's the processor support. So the processor support is one which decides the choose of RTOS. Next is the memory requirement. So what is the processor support? The RTOS requires ROM. The RTOS requires ROM memory for holding the OS files, and it is normally stored in a non-volatile memory like flash. And coming to memory requirements, the OS also requires working memory RAM for loading the OS service, and it is essential to evaluate the minimal RAM and ROM requirements for an OS. So the third point is real-time capabilities, functional requirement. So which OS behaves in real time? That is selected based upon the task scheduling policies. Kernel and interrupt latency. Kernel of the OS may disable interrupts while executing certain services, and it may lead to interrupt latency. Inter-process communication and task synchronization is one more requirement. Moderation support. It is useful for OS to support modernization, wherein the developer can choose the essential modules and recompile the OS image for functioning. And the next support for networking, support for networking and communication. The OS kernel may provide stack implementation, driver support for bunch of communication interfaces and networking, development language support. So development language means you can embed development languages are two types: high level embedded C, C++ or assembly language. And the non-functional requirements which decide how to choose an OS is custom developed or off the shelf. So custom development, you have to create your own OS or OS ready-made available, or cost of the OS, development and debugging tools availability. So OS tools availability and debugging tool in case of any performance issues, easy to use, and after the sales in the form of email and online services, debugging critical path issues, support for production issues must be analyzed thoroughly. So in this topic we have covered the topic called task synchronization and device drivers and how to choose an OS. So with this, I will conclude my topic.